Hi, I'm Jared with Funsciencedemos. If you think about it, science is everywhere. Science is also in stories. We found a lot of science in this great book, Those Darn Squirrels by Adam Rubin. In the story, a group of creative and crazy squirrels has to figure out a way to get around the obstacles that an old man puts in their way to guard against his bird feeders. We found a lot of science in this book, especially in the part where the squirrels engineer and design ways to get around the obstacles by building catapults. And our catapult design today features the clothespin. Believe it or not, this clothespin has elastic energy from a spring in the center. That's the metal part. When I pull this clothespin apart, I can see the spring more closely. That is going to power our catapult. We've zoomed in so you can get a closer look at how our catapult's going to work. Now here's a standard clothespin. You can see the elastic energy at work. When I push down on one end, it automatically closes. If I do some simple switching and changing, I can turn this clothespin into a catapult. And we want to start by pointing out that we recommend using clothespins that have the two slots on the end. Those slots are going to be important, and those are the clothespins you want to use, not the smooth ones. So we start by pulling apart the clothespin, and we want to do this carefully to keep the spring attached to the bottom part of the clothespin. To do that, I'm just going to simply lift up. You can see I get some separation when I pull apart. I'm going to lift up and pivot off to the side, and I want to make sure I keep the spring on the bottom clip. So I have it apart, and now I'm ready for the next step. So you can see my spring is still in place. What I'm going to do is spin this leg of the clothespin around so the slots are facing up, and I'm going to have to try to get this leg of the clothespin underneath that spring. But it's tricky because that spring is tight, that spring is strong. That spring is going to power our catapult. So I find using another clothespin really helpful. So I pinch this together in my hand. So you'll notice the spring is catching on the edge of that clothespin. I push down, I have a little bit of space, and that allows me to slide this under. Now I want to keep sliding until I get it in that second slot. Just going to wiggle it back and forth until it sits in, and now I have the beginning of a catapult. Now when we were designing this catapult, we noticed something right away. It was very difficult to hold our catapult. When I push down on this arm of the catapult, the whole thing wants to lift up. So we needed to make the base of our catapult longer. And to do that, we're going to use a popsicle stick. If I could attach a popsicle stick to the bottom, I now have a little tab that can hold my catapult down. The best way to attach it, because it's such a tight space, taping it would be very challenging. If we wrap a rubber band a couple times around as we just loop it, get it pretty tight, and that should hold the base of my catapult. Now you'll notice the front of my catapult lifts up. We're going to keep it loose, see how it launches, and then we have an actual strategy to fix that later on. Now we're ready to work on the launch arm of the catapult. And right away I can tell I need to make it longer, and another popsicle stick will be perfect for that. That gives me a longer arm and then a space to attach a basket or a holder to hold what we were going to be launching, our candy squirrels. So the next step we have to think about is how to attach the holder or basket. Now we found these tiny little cups work perfectly. This one's made out of paper. This one's made out of plastic, and what's nice is it's very easy to cut little slots in the bottom that allows a popsicle stick to slide through. It's quite sturdy. You can see the popsicle stick right there, and it fits perfectly. So I'm going to grab a cup, cut some slits, and see if I can slide it on my catapult arm. So we have our catapult assembled. Now comes the fun part, testing it. We found that dot candy is the perfect thing to launch. This is going to be our candy squirrels. Load it into the basket, pull it back, and it launches perfectly. Let's try it straight on to see what kind of shot we get. Perfect. Now, even though our catapult works, we think it can work better, so we've zoomed in so you can see the problem with our catapult. When I push the catapult down, you can see the front end of the catapult lifting up. I wonder what would happen if I took a rubber band and wrapped the rubber band around the front part of the catapult. That's probably going to hold it stable, and I guarantee it's going to add more elastic energy to our catapult. Let's see what happens. So you can see we've added a rubber band to the front of our catapult, but notice what I did. I didn't just loop the entire rubber band over the working arm of the catapult. I also attached it around the nose or the very front. So watch what happens. As I push down on the catapult, you can see I've added an energy source with those two rubber bands stretching, and I've stabilized my catapult in the front. Let's see if it works better. Okay, it's time to test out our changes and see if it goes further. 3, 2, 1. It went further. A big part of science is measuring. The nice thing about this catapult is we can measure how far our candy flew. We can also make changes and measure again to see if it went further. I can wrap this rubber band 3 times around the front, or 4. I could add another rubber band, and I can keep measuring to see if that actually makes my candy fly further. Remember, every time I wrap that rubber band around this catapult arm, I'm adding more energy. We'd like to give a huge shout out to Adam Rubin and his great book, Those Darn Squirrels. Those creative squirrels inspired so many of our catapult designs. Science is so cool. If you want to learn more about forces in motion, check out our YouTube channel, Funsciencedemos. And it's even cooler when I try launching more than one thing. Thanks for watching.